someone at an FYI that you talked about. I can't remember who, so thank you. But it's an interesting paper and something that I think we want students to come out of uni, not just well-trained workers, but people who have the capability to shape the future of their professions and their societies, which is more than just being able to do a particular job. And I think that's really worth thinking about that. Like if we're talking about engineers, yeah, maybe they need to know how to use MATLAB or Maple for their job, but we want more than that. We want them to be able to shape the future as well as to just do the things that we think they need to do now. And we want them to come up with an appreciation of the maths and stats, both its utility, but also its aesthetic beauty. If they're missing that, I think it's a real shame. And last, I've got a little pyramid of Bloom's taxonomy here, but I want to say that, like, if you read the literature and everything, all students should always learn at all levels of Bloom's taxonomy. I actually don't think that should be a given. Obviously, we want people to be able to think at higher levels and have lower level mastery, but they don't. I argue that they don't have to do it all at the one time. And there may be an argument for having a subject where they're working down here and just learning basic mastery skills, followed by a subject where they're working up here, or maybe not. But I think it's something that needs to be thought about and not just something that's taken as a given. Exactly where you want your students to be thinking and working at any particular time. Okay, how should we teach them? Whatever we choose, we've got to be aware that students learn things that we don't intend to teach them. And it's good to actually think about that. The most obvious one is that students decide what's important by the way they're assessed. And so it doesn't really matter what you tell students, if your assessment happened to be, and I'm using really simplistic examples throughout just because it's easier and I don't have to explain so much nuance, so forgive the oversimplifications, but if your assessment was purely multiple choice computer mark things, students are going to get the message that maths is only about getting the right answer any which way. And it doesn't matter what other messaging you give them because that's what they deem important. And that's sort of a hidden curriculum. Another aspect to be aware of is the other skills that you expect them to have in order to be able to grapple with the mathematics. As an example, if you were teaching statistics and you were doing it through R, and so they're expected to be able to program in R to get near the statistics. In a badly designed course, what can end up happening is the students just spend their time desperately trying to figure out what line of code they need to type in the syntax and never get anything out of the statistics at all. So being aware of the hidden curriculum behind what you're teaching is also really important. And in terms of what can we teach them, equity does come into this. Students who are coming from mathematically disadvantaged backgrounds come in with a lot less knowledge and fewer skills, which means that they can't get taught as much at uni. They go out at a lower level and you're perpetuating the disadvantage. It may not be something that we can go about changing, but it's certainly something we should be aware is there. Okay. And so this last slide is kind of more specific aspects of thinking about teaching and learning in maths. And so the first few things I've got are essentially where the debates and discussions tend to be centred. So out of the pool of topics, which ones do we choose to show them? Where on the continuum between technical mastery and conceptual understanding do we stop? How much of their work should be done by hand? How much should be done by? How much of our instruction should be explicit, direct instruction? How much should it be constructive as self-discovery by the students? And it's obviously an important point, and it makes sense that this is where the issue is. But at the same time, they are all continuums, and no one size can suit all, can fit all. And it doesn't matter where you put the balance point, it's not going to be perfect. If you move it this way, you'll help some students, you'll make it worse for some students. It's inevitable. It's just not possible to find a perfect point for everybody. And so, but they're obviously there's still better and there's still worse, but exactly where the sort of optimal range is, it's a bit of a social construct, and it's going to depend on the group of students in front of you and on teacher preferences and the interaction between them. And so it will differ for different groups of students, but it can also differ for different teachers with the same sort of students, just depending on how those interactions are working. So it's important, but you're sort of looking for holy grail if you're looking for perfection there, because it's just not possible. Back to Bloom's taxonomy. This is up here because I wanted to say something about what I'm going to call internet technologies, the idea that you can just look things up. And what seems to be happening in education, how do I make this thing turn red? Can I do that? It doesn't matter, I'll just jump. So what seems to be happening is with internet technology showing up, it's pushing things down the pyramid. So problems and ideas and concepts that you used to have to wrestle with and sort of synthesize and evaluate and pull in things from different sources, you can now just look up. And so what's happening is that's moving these problems from higher order thinking down to simple remember and regurgitate at the worst level, or, you know, understand and apply at the next best level. And that's not what we want. But the interesting thing, what interests me here is that for us, the internet tools do the opposite. They let us get through these levels much faster so we can jump up and start playing with the fun stuff much quicker. And I think a really interesting question is, how can we deliver content to students so that they get the same effect? I don't know of anyone talking about this at all. I hope someone is, and I'd be really interested in hearing about it. But I think that's a really interesting question, because it seems that we're getting different things out of the availability of knowledge to what the students are, and can we change that so that they benefit the same way that we do? All right, so time to reflect. I think we're all going to agree that something like rote learning for your exam and then probably forgetting it afterwards is pretty pointless. And it's really, really, really not what we want. We want them to learn any maths and stats in a way that it sticks. So they construct some meaning, and that meaning actually stays with them and doesn't explode. And if you teach the content without linking it to their other experience and other learning, that lends itself to the rote learning and forget model, simply because if you're trying to learn something that you can't map to your existing experience, it's very hard. And if you're under time pressures, it's much easier just to rote learn it and forget it and get nothing out of it. So the only way you can do this is by giving students time to struggle and reflect. And there's many, many different ways of doing that. But if it's not built in, it's unlikely to happen of its own volition, except for a very small cohort of students. And obviously time is at a premium. There's a lot of pressure to cover the required content and so on. But it's worth bearing in mind that people who learn one thing well tend to be more easily able to learn other things well when compared with people who learn multiple things shallowly. So it's worth having some time for depth somewhere and not cursorily covering everything, because it seems that people will get more out of everything if they understand something at a deeper level. And this one I like. Look out for things that will improve outcomes for all. They do exist. The example I thought of doesn't come from maths. Don had to help me find a maths example, but the example that I thought of came from a primary school teacher, and this teacher was getting a student in her class with some emotional regulation issues. And one of the many things that she did was she printed out a little thermometer, coloured thermometer, and stuck it on every kid's desk together with a timeout card. And then she took 5 minutes, literally 5 minutes, to teach the class, you know, this is you just check after every break or each activity, just have a look at this and see what you're feeling. And if your stress levels are getting up to a 7, give me your timeout card and go off to the bubblers and have a drink and just come back when you feel better. It's something that it was very low cost. The students who were cool cucumbers, they didn't need it and it did no harm. But for the child in question and for a lot of the other children, there was a benefit to having it there. It was an all-round win with no downside. These things really do exist. It was the first time I'd seen such a thing, which is why it stuck. The example that Don pointed out to me was some of Amanda's work looking at embedding anxiety management programs inside statistics subjects for students. And that seems like it should be something that improves outcomes for everybody. If you're not anxious about statistics, fine, you know, you waste half an hour or whatever it takes. But on the other hand, you're getting some skills that you can use if you're ever anxious at some other time. And if you do have stats anxiety, it can be a game changer for you. So it's really worth thinking about things that can improve everybody's outcomes, even if they're outside the traditional thinking box. Consistency is all important. Consistency of purpose, that is, not conformity in delivery. It's, you know, in terms of delivery, students all have different learning preferences. Teachers have different teaching preferences. Why would you want to make everyone do everything the same? That's not, but consistency of purpose. So the same messaging throughout, that's really important. If you get mixed messaging, then at best case, you get a random outcome, and at worst case, you just get confused, disillusioned students. As a really simple example, if you had a subject where, if you had students who had to study 2 subjects, in the first subject, maths communication is all important, deep understanding is all important, that's where it's at. And then the second subject, it's all multiple choice marks. And so only the right answer matters. You tend to end up with incompetent autonomous, the worst of both worlds. You know, if you only did multiple choice, you might get competent autonomous. If you only looked at deep understanding, you might get people who are highly conceptual understanders. But you need a single message, a consistent message, whatever that message is. Consistency is better. And also consistency in sort of the additional things they need to learn. So consistency in nomenclature, consistency in software that they have to learn, and things like that. So they're not getting so overloaded by side issues that they can't focus so much on the maths. Takes me.
Sorry.
It likes me again. Thanks, Jonathan. Will it make them love maths more? I want to say really simply, if you have a course and the students come in and they come out convinced that maths sucks and they hate it more than they did before they started, there is room for improvement. I'm not real good with this, am I? Oh, it's there at the bottom, sweet. Okay, so yeah, I want to finish with a hyperbole. Like all hyperboles, it's not true, but it's much more memorable that I tried to say precisely what I wanted to say in a nuanced fashion, and there is a kernel of truth at its heart. All right, that's everything I wanted to say. So now we get to do the fun discussion. I'll put down this before I break in.